Write the equation for the circles with the following characteristics. Part A, the center is at 1, -2, and the diameter is 10. So you want to start with the basic equation for a circle, x minus h, the quantity squared, plus y minus k, the quantity squared, equals the radius squared. And that's for a center of hk. So since our center is 1, -2, we'll have x minus the x value of the center, so that's x minus 1 squared, plus y minus the y value of the center, y minus -2, the quantity squared, equals the radius squared. But since the diameter here is 10, that tells us then that the radius is half the diameter, so the radius is going to be 5. So 5 squared here would be 25. So the equation for this circle is x minus 1, the quantity squared, plus y plus 2, the quantity squared, is equal to 25. Part B, we also have the center. We know the center is at -3, 0, but this time we don't have the diameter or the radius, but rather we just have a point that lies on the circle. So the circle contains the point 1, 2. That means that this point 1, 2 lies on the circle. So I would still recommend starting with the basic equation for a circle, and in fact I would write this equation down every single time you use it. That's just going to be a strategy to help you remember it. And since we do know the center, we can go ahead and substitute those values in place of h and k. So x minus the x value of the center, which is -3, so x minus -3, the quantity squared, plus y minus 0, the quantity squared, is equal to the radius squared. So right now we have x plus 3, the quantity squared, plus y squared is equal to the radius squared. But we still need to figure out the radius. So that's what's left here that is unknown. And there's basically two different ways to figure out the radius. And I'd recommend that you draw a picture anytime you're stuck. Remember, a diagram is a great place to begin. So if the center of the circle is sitting here at -3, 0, and if the circle contains the point 1, 2, again, that means that this point, try that again. This point right here, there it is. That point 1, 2 is on the circle. So that means then that the radius is from the center to the circle. So this line segment would be my radius. In other words, if I were to try to draw this circle in, my circle is going to look something like that, where this point 1, 2 lies on the circle. So there's essentially two different methods for figuring out the radius and then the equation for the circle. So what I would call method 1, let's say, method 1 would actually figure out the distance between the center and the point 1, 2. And if you've studied the distance formula, then you know how to figure out the distance between 2 points. So method 1, we're going to use the distance formula. So to figure out the radius of this circle, we're going to use the distance formula between the 2 points, -3, 0, which is the center of the circle, and 1, 2. So let me jot those points down here. -3, 0, and 1, 2, and we're going to compute the distance between those points using the distance formula. So the distance formula says that we're going to subtract our x values. So that's -3 minus 1, the quantity squared. The x values are being subtracted. Plus, we'll subtract our y values, and that would be 0 minus 2, the quantity squared. And then we'll simplify, and this will give us our radius. So we'll have -4, the quantity squared, plus -2, the quantity squared. That'll be 16 plus +4, which will give us the square root of 20. Now, of course, you can simplify the square root of 20. However, if we go back to the equation that we're working with right now, here's the equation that we have so far for our circle. So the only thing left to find is just the radius. And you'll notice that once we know the radius, we're going to square that to put it into the equation for the circle. So there's really no need to simplify our radius here because we're going to end up squaring this quantity for the equation of the circle. So again, going back to the equation that we had so far here, what I have in yellow, we have x plus 3, the quantity squared, plus y squared is equal to the radius squared. But now that we know what the radius is, we can substitute that value in. So x plus 3, the quantity squared, plus y squared is equal to my radius, which is the square root of 20, squared. And of course, when we square the square root of 20, that's going to undo the square root. So we'll ultimately end up with x plus 3, the quantity squared, plus y squared is equal to 20. And this will be the equation for the circle that has a center at -3, 0, and contains the point 1, 2. So that's one method. This is utilizing the distance formula to find the radius. Now there's also a second method for finding the equation for the circle that does not involve the distance formula. So if you're a person that's thinking, I don't think I would remember the distance formula, that's not something that I recall, then you don't have to use it if you don't want to. So method 2, you'll notice I still have to set the equation for the circle up utilizing the center. So I'm still here at x plus 3 squared plus y squared is equal to the radius squared. But rather than using the distance formula to find the radius, instead, let's utilize this point right here that we know that is on the circle. So this point, 1, 2, is a point that lies on the circle, which means that when x is equal to 1, y is equal to 2. So this x and y value must satisfy our equation here. So right here, when x is equal to 1, y must equal to 2. So we can substitute in 1, 2 for x and y, and that's going to let us solve for r. So here's what that looks like. So in place of x, we'll substitute in positive 1. So that would be 1 plus 3, the quantity squared, plus, in place of y here, we'll substitute in positive 2. So that's 2 squared is equal to my radius squared. So see, now we've substituted in the x and y value, and now you can solve for r. So this will give us 4 squared plus 4 equals the radius squared. 4 squared is 16. 16 plus 4 is the radius squared. Therefore, 20 will equal the radius squared. Now, you could go ahead and square root both sides here if you wanted to find the radius, but remember, when you take a look at the equation for the circle, you're going to take the radius value and you're going to square it. So you might as well just leave our radius squared here as 20 because that's going to get substituted in place of r squared. Therefore, you do a little substitution and you have your equation. So let me make a little room for that equation right here. And you'll notice, of course, it's the equation that we had before. For the circle, x plus 3, the quantity squared, plus y squared is equal to 20. So there's the equation for the circle without using the distance formula. Instead, you substitute in the x and y value of the point that you know lies on the circle. And now part C. So part C gives us the endpoints of the diameter. So once again, let me start with a diagram. So -2, 4 is one of the endpoints of the diameter, and +3, 6 is another endpoint of the diameter. So in red here, this would represent the diameter, that line segment. Therefore, my circle would look something like this. You get the idea. So once again, you start with that equation for a circle. However, on this problem, we don't know the center. On the previous two problems, we did know the center, but on this one, we don't. We don't know where the center is. So we must start by finding the center. We know the center is going to be the middle of this red line segment, the middle of the diameter. Therefore, we can utilize the midpoint formula to find the center of the circle. So remember that a midpoint is found by taking the x values, adding them, and dividing by 2, which means you're averaging. So if you average your x values and then average your y values, that will give you the midpoint of any line segment. So my endpoints were -2, 4 and +3, 6. Therefore, the center of my circle, we will average my x values, -2 + 3 divided by 2, and my y values, 4 + 6 divided by 2. So this gives us a center of 1/2, 5. So now that we have the center, we can go ahead and substitute. Remember, this is h and k. We can substitute these values into my general equation for a circle. So right now, we have x minus 1/2, the quantity squared, plus y minus 5, the quantity squared, is equal to the radius squared. And now, once again, just like in part B, the previous problem, you have two options. There's two different ways of finding your radius. So, method 1, let's utilize that distance formula again. So to use the distance formula, we have two options. We've determined the center from our previous work here. The center was 1/2, 5. So we know the center right here. And we could certainly do the distance formula from the center to one of these points on the circle, and that would determine the radius. But the drawback to doing the distance formula using our center is that we could have made a mistake. We don't really know for sure that the center is correct. So I tend to not use the center in this example. I prefer to use the points that were actually given in the problem. So if we compute the distance from -2, 4 all the way over here to 3, 6, that's actually not going to be the radius, but rather that's going to be the diameter. So I'm going to use the distance formula, and the distance formula is going to allow us to figure out the diameter of this circle this time. So the distance between these 2 points. So we'll take our x values, -2, and we'll subtract them. So -2 minus 3, the quantity squared, plus 4 minus 6, the quantity squared, will be our distance formula. Simplifying, we have -5, the quantity squared, plus -2, the quantity squared. So we end up with 25 plus 4, which is the square root of 29. So again, remember, that is the diameter of our circle. That's the exact form, square root of 29. But if you go back to the equation for the circle again that we have so far right here, we know that we need the radius, not the diameter, but the radius. So to figure out our radius, we're just going to take that diameter and we will divide it by 2. So the radius is the square root of 29 divided by 2. So back to the equation for the circle that we had in our previous work here, x minus 1/2, the quantity squared, plus y minus 5, the quantity squared, was equal to the radius squared. And now that we know our radius, we'll just go ahead and substitute that into our equation. So that gives x minus 1/2, the quantity squared, plus y minus 5, the quantity squared, is equal to our radius, which was the square root of 29 divided by 2, but now that has to be squared. So x minus 1/2, the quantity squared, plus y minus 5, the quantity squared. And then we need to go ahead and simplify this. So when you square the numerator, that'll just leave us with 29, and then square the denominator, which would leave us with 4. So here's the exact form for the equation of this circle. So method 1 utilizes the distance formula. Now, of course, as I mentioned before, you don't have to use the distance formula at all if you prefer method 2. Now, let me backtrack again. You still have to start this problem the same way. We still have to find that center first and begin with our equation for the circle, where we've inputted the center but we don't know the radius. So let me go ahead and copy that equation, what we had so far. X minus 1/2, the quantity squared, plus y minus 5, the quantity squared, was equal to the radius squared. So now we want to find the radius, but we do not want to use the distance formula. So again, if you're trying to avoid that distance formula, just take a look at your circle and notice you have a point, in this case actually 2 points, but you have 2 points that actually lie on the circle. So for example, if I look at 3, 6, that's an x value and a y value. That should make this equation true. So by doing just substitution for x and y, we can then solve for the radius, and you don't have to do the distance formula. So I'm going to substitute 3 in place of x and 6 in place of y. And now, of course, you could have substituted -2 and +4. That's entirely up to you. It doesn't matter which one you choose. Of course, sometimes we make fewer mistakes substituting in positive values. So that's why I chose 3, 6. So now I'm substituting, and I'm just going to solve for r, for my radius. So 3 minus 1/2, that's going to be 2.5. You might find it's easier to just stay with fractions here. So 3 is really 6/2. So 6/2 minus 1/2 is going to be 5/2. And of course, that is the same as 2.5 squared. Plus 6 minus 5 is 1. So 1 squared is just going to be 1, equals my radius squared. So that's 25/4 plus 1 equals the radius squared. And 1 is really 4/4, so if we add our fractions, we end up with 29/4 is equal to the radius squared. Once again, looking at this equation for the circle, our unknown, what we were left to find here, was the radius squared. So there's really no need to square root both sides, because we can just take this value, 29/4, and substitute it into our equation, and we're in business. So the equation of this circle is x minus 1/2, the quantity squared, plus y minus 5, the quantity squared, is equal to 29 divided by 4. And we were able to obtain the equation for the circle without using the distance formula.